Hello, and welcome to the Marston Science Library Guide to Arduinos. Today we will be working on the Pseudo-Theremin tutorial. Our goals today are to learn how to use analog read function to detect the amount of light from a photocell, learn about translating notes to frequency in Hertz, learn how to use tone to create simple sounds out of the piezo, and learn about the theremin and replicate this instrument. For this Pseudo-Theremin tutorial, the electrical components you will need include the Arduino Uno board, a breadboard, a piezo, a photocell, and a resistor, as well as 4 jumper wires and the USB cable to connect to your computer. In this setup, imagine that we have 2 circuits. Both start and end at the Arduino. In the first, we take a wire from the 5-volt to the breadboard to provide power. We then use the same row to connect our photocell to send current through it. The second leg of the photocell, of course, will go on a separate row. The current will then run from the second leg of the photocell to A0 to send the analog data being collected from the photocell back to the Arduino. We'll use a separate wire to connect this leg back to analog pin 0. The same row needs one leg of the resistor, which is bidirectional, and the resistor needs to bridge the breadboard to another row that can be grounded. The grounding wire goes from that row in the breadboard back to the ground pin on the Arduino, completing circuit 1. The Arduino now has the data it needs to determine how much light is shining. So for output, we take a wire from the Arduino digital pin 8 to a new row on the breadboard. This provides data and current. On this same row is the red wire of the piezo. The black wire of the piezo should be grounded in the same row as the resistor. There is more than one correct way to build a circuit. You could separately ground each circuit, but this is the setup we'll be using for now. The first thing we want to do is copy and paste our Arduino code from the website to the Arduino Integrated Design Environment, also known as the app. I have now copied and pasted our code. As you can see, integer, void setup, void loop, analog read, and tone are all highlighted yellow, as these are functions that the Arduino code recognizes. We next want to save our code. Go to File, Save. In our code, we will first declare our variables. Integer piezo will be mapped to digital pin 8. Our integer photocell will be mapped to analog pin 0. In our void loop function, we will ask analog read to read the value of photocell on analog 0 pin and turn that into our integer light input. We will then say that the integer frequency equals 200 plus light input divided by 4, and then we will ask the Arduino to produce a tone on our piezo pin at the frequency that the light input has requested. If you ever have any questions about code in the Arduino, please refer to the Arduino reference page, arduino.cc/en /reference/homepage. The Arduino sketch is actually really straightforward. We simply take an analog reading from analog pin 0 to measure the light intensity. This value will be in the range of something like 0 to 700. We add 200 to this raw value to make 200 Hz the lowest frequency, and simply add the reading divided by 4 to this value to give us a range of around 200 Hz to 370 Hz. Now that we have compiled our code, we can upload it to the board. We'll need to connect our USB and upload. If any of your pins have become dislodged, you may need to fix it. We can now hear that the piezo is giving a certain tone. It changes depending on how much light the photocell is receiving. And there you have it, a pseudo-theremin. Thanks for joining us!